Hello everyone, my name is Dr. Ashbaugh. I'm here to walk you through cluster analysis and the using of the virtual computing lab for those that have not done so before. So we're going to do something in analytics, and it's a really neat tool that can be used to help your business make more money. And you're in business because you like money, hopefully. And let's learn how to make a little more of it. So the first thing we're going to do is get to the virtual computing lab, and you get to it from the homepage. You can either type vcl.ncsu.edu, or I always do it from the search and find VCL this way. And here we go. Virtual computing lab, what is it? It's a bunch of servers that students and a lot of partner institutions can log in through this to work on some very expensive pieces of software that would be too expensive to divvy out to everybody in the university. So what they've done is they've created a bunch of servers that can be imaged with whatever specialized software that you need, and we can access it from home. So this is VCL, and what we're going to do is we're going to make a reservation. And we make a reservation through here, and I'll say new reservation and do it. But before I do a reservation, I have to talk about there are differences with computer systems. I'm using a PC for this demo. There are those that use Macs, and if you do have a Mac, there is help and documentation here that can bring you to how to do this with a Mac. Most of the mechanics are the same, although you need to download an app to run the virtual computing lab if you have a Macintosh computer. The software to read RDP file, remote desktop, is built into Windows machines. It's not built into Macs. There's an app that you can do it, and how to find it is through this help and documentation. You can find it through frequently asked questions. How do I connect from a Macintosh? And basically you'll need to have one of these remote desktops. And in the spring, 10 wasn't stable, so people used Microsoft Remote Desktop 8. It's a safe program to download to your Mac. And what you would do is open the RDP file that you get from the reservation through this application. If you have a Linux machine, there's instructions for that. Other things that you might want to consider is if you are on a PC, it will make it easier for you to do this assignment if you map your drives. So I'll go back to reservations here. And if we go to manage my user preferences, there's an RDP preferences. And if we look at that, and sorry about the jigging, it does that with my machine. It's not anything to do with the video. But see this map local drives to yes? This is very handy. I can map it to my hard drive, which is slow, or faster to put a thumb drive in, and the thumb drive will map through to this Blade server that's going to run the image with that expensive software that I can't afford to buy myself. So I recommend that you do this. Now for this demo, I'm going to map it to my hard drive. I would always do it with a thumb drive normally, except I only have 2 USBs on the computer I'm doing this, and one's with the microphone, one's with the mouse. So I'm not going to do it with a thumb drive. It will take a little bit longer to do the demo. I apologize in advance. So again, make sure you map your local drive if, again, you're on a PC. So I'll go back to reservations, and when it's time to make a reservation, we're going to make a new reservation. And there's a lot of images here. There's all sorts of software here for all different courses. There's some for computer science. There's some for industrial engineering. There's some for mathematics. There's a lot of different stuff. And again, there's going to be a PCOM one that we're going to use later for a project. Doesn't work the same way as Virtual Computing Lab, but this is where we access it. So we're going to come down and we're going to use a program, SPSS Amos 25 or 26. It doesn't matter. 26 is the latest version, so I'm going to use the latest version. 25 and 26 basically work the same, so we can do it. I'm going to create a reservation for now, and then it's going to pop up. And if you look at my screen, yes, it's 3 in the morning, and why it's 3 in the morning and I'm doing this demo is because now I'm not likely to have to wait for an image to be ready. If I did this during the middle of the day, potentially there could be a lot of people trying to use the virtual computing lab at the same time, and it might be 20 minutes until my image is ready, and I basically don't want to bore you to tears for 20 minutes waiting for my reservation to come in. So I figured I'd do this real late at night when there's nobody using the virtual computing lab, and I can get this thing done for you. And again, it took less than a minute. So what happens is a computer in a rack of computers has been imaged with the software SPSS, which is a very expensive piece of software from IBM that does statistical analysis. A site license is about $10,000 for this piece of software, so it's not something that we're all going to have on our computers. But having it on Virtual Computing Lab means that everyone in our class or at the university in general can have access to this very powerful piece of software. So now I'm going to connect, and it tells me here's the computer I'm going to use, 152.46.19.132. That is the IP address of the computer I'm going to have tunnel into my computer. This password is not my password, so if you think you're going to hack me, good luck with that. This password is a temporary password just for this remote session. And when you create a remote session using VCL, you will get a temporary password also. I like to copy this because this is hard to remember for me, and I'm a slow typist. So I'll copy it, and then when I say get RDP file, I'm going to open it. And then it's going to be this warning that's going to completely destroy my computer if I use it. Well, not really. I trust NC State. We've got some very good IT people, so this is safe to do. I'll connect. And then here's that password. I'm going to paste in the password that I copied here. And here I go. Oops. Apparently I didn't copy correctly. All right, let me try this again. All right, so when you do that, you'll get another thing that says, warning, your computer is going to be destroyed by hackers. Well, not really. Again, I trust NC State's IT department, so I'm going to go ahead and connect. And right now it's connecting to a computer that's in a room at NC State. And here it comes. This SPS Amos 26 image is coming up. And again, see, it's under a different operating system. I'm running Windows 10 here. And this is a Windows 7 operating system where this software SPSS is. And this is the software we're going to use. So one thing, I have to get the file I'm going to use. So there's a couple ways to do it. And one way you can do it is go ahead and go to Chrome or Firefox, whichever browsing that you like. You can pull up the Moodle site and download the file directly from the Moodle site. I've already downloaded it to my machine, so I'm not going to do it that way because I've mapped my drives. This C is actually my drive. And there I am. That's the name of my computer. And I've got lots of files out here. And hopefully I will see my documents. Oops, wrong one. So my documents. And in my documents is a file called cluster analysis, and it'll be the same file that you go ahead and download from Moodle if you're doing it that way. Again, I like to do this on a thumb drive. It's much faster tunneling through with a thumb drive. But my USB ports are all full, so I'm doing it through. And here's my cluster analysis. And what I'm going to do is I'm just going to move it. Just copy it over to the desktop here. Okay, and by the way, when you leave a virtual computing lab, when you close it up, this computer will get wiped. So if you have work that you saved onto the desktop, don't worry that someone's going to steal it. It's not. It's going to get wiped. But if you need that work later, it's not going to be available to you because it's going to get wiped. So just a little words of warning for you. All right, so I have my file. I'm going to pull up this software. And again, SPSS is an IBM product. The site license is about $10,000. It's used by a lot of marketing companies because it's a very powerful statistical tool. Now, I used to work for cruise lines. I used to be a consultant, and the cruise line I worked at, we used a lot of stuff to try to figure out what causes people to buy. How do we figure out which customers are more likely to book cruises with us? And for ones that sailed with us, which ones are more profitable for the company so that we can maybe add discounts for them so that they'll book again because they're very profitable for us. And so a lot of big data tools we use to try to figure out who those are so that we could better spend our advertising dollars to get more profitable customers. It's nothing new. Marketing generally has gone into analytics in a big way. If you are someone that wants to do marketing, more power to you. But if you think you're going to do it the old way of Mad Men, just have a good idea for advertising, those days are sort of past. Now we expect our marketeers to understand demographics, to understand databases, understand customer demographics, understand how to be able to create queries and come up with which customers are better bets to advertise to. That's where the world's going. So what I'm going to do is I'm going to pull up a new data set. And the one is going to be this one on the desktop. So I'm going to import data, and I'm going to import an Excel spreadsheet. And I'm going to do it from my desktop. And there's my cluster analysis. Okay, and then here it goes. Now, notice there's no labels in any of the data. There is another file that you're going to do yourself that does have data labels. If you do that, you would have to check this box, read variable names from the first row. Since there aren't any data names in the first row, don't check that box. And I'm going to go ahead and just upload it. And it will take a second because there's over 1,000 rows, well, there's about 1,000 rows of data. So here's our data, and there's no labels, so what's in here? Well, I happen to know what's in here. And so what I'm going to do is use the variable view to do metadata. What's metadata? It's data about data. So I can put in what these variables actually are. This first one is actually a company number. The next one is the number of employees. And the last one is profit. Now, one of the things is there's different types of data, and some data is more useful than others. Now, company number is data, and in this case, it's a number. The number is 1 to 1,000. You have to ask yourself, does it matter what number a company is? Is company number 1 better than company number 50? Is company 50 50 times better than company 1? And in this case, the answer is no. They're just randomly assigned numbers. In most databases, when you put things in a database, you can assign a random number. or a sequential number. And so there'll be a number tied to a data element that's just for record keeping. It doesn't tell you anything about how good or bad a company actually is. And so we don't really want to sort on a data type like that. Really, that's called nominal data. Nominal data is basically arbitrary. Which color is better? Well, red is better, but to some people, they like blue. Who knows why? But some people like green. Is green better than red? Better than blue? Well, who knows? It's data, but there's no order to it. And so we call that nominal data. Another type of data is ordinal data, and we fill out a lot of surveys. 1 through 5. Do you super much like it, or do you super much hate it, or somewhere in between? But a 5-point scale is really sort of arbitrary. Why not a 100-point scale? Why not a 10-point scale? Is a 5 twice as good as 2.5? Maybe. Depends on how your categories are. Is 100 twice as good as a 5? Or, well, they might be the same value just on a 5 scale versus a 100 scale. So that's called ordinal data. There's interval data, which you look at different intervals of data. And then there's ratio data, which has a true zero. So length is ratio data because you can have a 0. Can you have a negative length? Not something physical. Time, volume, temperature, if you're using Kelvin scale or Rankine scale. If you're using Celsius or Fahrenheit, the 0 is sort of in an arbitrary place. So there's different types of data, and again, you can have this stuff in your basic stats class. But because the company number is really arbitrary, I'm just going to make it string so that we don't use it for any of our analysis, because it doesn't give us anything. All right, and that's our data. So the next thing we do is, okay, I got the data in there. Now what am I going to do with it? Well, let's do some stuff. Would we like to know about the data? So we can do descriptives. That was embarrassing. I'm sorry. So what we want to do is, do we want to know stuff about number of employees and profit? Sure, why not? Say okay, and our data views will find out some descriptions. And our descriptions are stuff like n, number, minimum, maximum, mean, standard deviations, all that stuff that tells you about the data. So our number of employees is a minimum of 51 and a maximum of 5,000. The minimum profit is 15,667, and our maximum is just under $1 million. We have means of both, and again, careful of means when you deal with money, because you could have a case where Bill Gates buys a trailer in a trailer park. He's worth about $100 billion. Everyone else might be worth $10,000. It would look like the average, if it was a 10-unit park, the average just went up to $10 billion a piece. And that's really not telling you much of the asset level of people in the park. It very much skewed towards outlier data, where a median would be a better unit. In this case, again, we have mean. And standard deviation, again, standard deviation, a measure of spread. The larger the standard deviation, the more spread there is to the data. Okay, well, we could have done this in Excel. Let's do something that's a little tougher for Excel to do. So we'll do analyze, classify, and we'll do something called nearest neighbor. Nearest neighbor will give us an idea what kind of clusters are in the data. It takes a little bit of time. And again, you can get a plot like this if you were to use a scatter plot on these two columns of data on Excel. If you want to do it, you're welcome to. But what SPS could do is tell us more about these different pieces, and that's the power of SPSS versus using something like Excel to do my analytics. So here we go. This is nearest neighbor. Looks like I have 1, 2, 3, 4, 5 clusters. Okay. What does that mean? Well, it tells you which, in this case, it's companies in terms of profit versus number of employees. And if you're a finance major, this might be very useful for you because you'll want to invest in companies. Which companies are probably going to have the highest returns? Well, these right here, high profit, low number of employees, right? We want to find companies here because these are most likely to have the best stock dynamics. Companies out here that are very low profit but a lot of people, well, there's companies might be past their prime. They might have grown. There might be competitive pressures in those industries. We'd much rather have, this higher profit group than this lower profit group. These in the corner here, these are startups. And startups generally are low number of employees and low profits because they haven't been around long enough. Now, if I'm an investor, I want these. I can make a lot of money here. I can make some money here, some money here. This is my dynamic. Yes, let's make a lot of money. Problem is, other people have access to the same information I do. So it might be the case that a lot of people have already recognized those companies. Okay, great. Why'd we do this? Well, if we can find out more about the companies here and find out what traits the companies in this group are doing that makes them high profit, low employee companies, and we can look for those traits in these startups, we can make bets on some of these startups and hopefully we'll have outsized returns if they do well. Now, placing a bunch of random bets on companies can go very bad. But if your bets are not so random because you're able to see things from these companies that are very successful, some of the same traits that are in these companies just starting, if I can find those, I can make a lot of money. And again, I don't have to be right with all the companies I invest in. I just have to be right more than I'm wrong. And in finance, you can make a killing. So we might want to know more about these companies, and how we know about what's in those companies we'll do analyze, classify, and I'll do a k-means cluster, and I want to find out more about those clusters. How many clusters? Well, last I checked there were 5, so I'll put that in there and say okie dokie. And when I do this, I will find that, yeah, here's my clusters. Here's number of employees, profit. Here's the final clusters, and we'll find out what are in each cluster. And in this case, which cluster is my target, the ones that I want. These guys, it's my cluster number 3. If I had more data about these companies, I could ask, okay, within cluster 3, what about other variables within cluster 3 that I might want to know more about? If you do cluster analysis with, like for marketing, for, cruise line I worked at, well, we did that and we found that, guess what? It turns out a lot of our customers like the show Nature in certain markets. And so we were able to sponsor Nature on PBS in those markets, and it was a very effective advertising strategy. We would never have found it out without some of this more advanced analytics. And again, you have good analytics, you can make more money. That's why we do this. That's why analytics is such a big thing now in what companies are expecting from students to hire. So, I hope this was enlightening for you. Again, I've just scratched the surface on this tool, but there is another file for you to do on this tool, and hopefully you'll have that a chance to do it. It will be most of the same data, but we're going to add states, so you're going to have more clusters because now we have more data points. And again, just take a look at how to do something like this, because it might be the case that this type of analysis makes you a lot more money. And as you think about your jobs coming forward, like if I want to be marketing, what kind of data do I want to collect? that might make a difference for me to find more high revenue customers. If I don't collect the data, I can't analyze it. So part of what you're going to be asked to do in some of these professional jobs is figure out, hey, which are possible differentiators that we can map and run some data analytics on, and hopefully get some ways to make more money. And in this cluster analysis, it's not just that. It's used for medicine. A lot of people are traditionally go to the Komen Race for the Cure for breast cancer, and it turns out that for a long time people thought it was one disease. And when they did advanced analytics on it, they found that it's not one disease, it's 10 different cancers that just happen to manifest in the same place. So once they found that it's really 10 different cancers that have 10 different risk factors and 10 different drug regimens that work, now it's much more survivable, because they can do a biopsy and find out, hey, look, it's this type of cancer. Okay, this type of cancer has these treatments that work very well. It's dramatically increased survival. Another thing for medicine that they're working on is, it turns out, Alzheimer's dementia is really not one disease. They're finding it might be at least 7. And so they're trying to do the analysis, because there's certain risk factors for certain types of Alzheimer's that aren't true for other types of Alzheimer's dementia. And if they could figure out what all those risk factors are for the specific types of diseases and find the drugs that they make that will react in certain types of diseases, we can potentially have some cures for that. And really, that's going to be $1 trillion idea when they get there. And they're going to get there with statistical software like this. So just trying to give you a preview. Sorry, I've rambled a little bit. But again, what you want to do is save this file out, upload it. I don't need to do that because I've already saved it and uploaded it. Again, there's a save function. You can export it as a web report. You can export, you can just do a save as. There's not a lot of options here. A web report, if you have the right viewer, might be able to work. The SPV file, you need this program to work. Unfortunately, there's not an easy way to do a PDF, but you'll want to save your data and have it ready to hand in. All right, I'm not going to save my stuff. Close it all down. I can wipe this file out. Oops. I can wipe this file out or not, because it will get wiped. But anyway, hopefully you learned a little bit about how to use the VCL and how to run a cluster analysis. So good luck.